In 1960, Sir Gordon Dobson first warned about the depletion of the ozone in the Antarctic. Since then, concern about the effect of chlorofluorocarbon CFC gases on the atmosphere has increased. In 1987, several countries signed the Montreal Protocol, designed to phase out the production of CFCs and hydrofluorocarbons, HFCs. Within the EU, a vote has been put into place to ban the use of these gases in refrigeration and air conditioning equipment. It is now necessary to replace the R22, still present in many installations, with a product that is environmentally friendly. For example, Furan 427A, which is a non-toxic, non-flammable refrigerant, which does not affect the ozone layer. This product is proven to be one of the lowest contributors to global warming among the R22 replacement gases. Possessing a low GWP, Furan 427A has been successfully used for over 5 years. In addition, Furan 427A is a competitive solution because it carries a cost of between 5 to 10 times lower than the cost to invest in new equipment. Furan 427A is the simplest solution to adapt to refrigerant equipment, adhering to European regulations. The reason being because of the lower cost, its easy use and versatility, and because it's effective in all applications. This will be demonstrated in a case study. In 1989, the Spanish company Bacalaos Pleamar, specialists in cod processing and trading, was the first company in the sector to be approved under the then new and demanding rules of the EEC. Ever since, Bacalaos Pleamar has been committed to adapt to new environment protection regulations. This company has several freezing and processing sites. One of them is a medium temperature preservation chamber with air conditioning using R22. In the first instance, we'll explain how to replace the R22 from the preservation chamber. Firstly, check that the equipment works properly. Take note of the installation operating parameters with R22. Medium pressure of high side pressure gauge, discharge. Medium pressure of low side pressure gauge, suction. High-medium temperature according to the gauge. Low-medium temperature according to the gauge. Superheat. Temperature of the chamber. Electrical power consumption. Once the data has been recorded, remove all the R22 from the equipment. Recover it in a labelled recovery cylinder or container using a refrigerant recovery unit. It will take approximately 180 minutes to complete this process. Once the gas has been removed, recover the oil. To do this, dismantle the sight glass of the oil level display and introduce a recovery bent copper tube connected to an oil pump. This is to make sure to get to the bottom of the sump, to remove absolutely all the mineral oil. Analyze the oil in order to check that there is no acidity. These checks also give an idea about the general status of the equipment. Following this, store the oil to be removed by an authorized waste management company. This operation takes approximately 10 minutes. After completion, close the sight glass level and add with the oil pump 2.3 litres of polyester oil according to manufacturer procedure. This will take approximately 5 minutes. After changing the oil, replace the oil filter dryer in 5 minutes. Then, pull a vacuum in the system. Once the system has been evacuated, wait for approximately 15 minutes to check that the vacuum has been kept in the equipment. This will confirm that the system doesn't have any leaks. Refill up the system with Furan 427A. Using 11.5 kilograms, which is around the 95% of the 12 kilograms of R22 that the system contained. It will take approximately 60 minutes to pull the vacuum and check that the vacuum holds and for completing the recharge. Now, it's time to start up the system. Take note of the pressure levels and operating measures, and then compare them with the previous data. Remember that the pressures and temperatures are not the same as working with R22. If it's necessary, adjust the expansion valve to the desired parameters. The startup and the resetting of the equipment takes approximately 40 minutes. Finally, add a label to indicate that the system is now working with polyester oil and Farane R427A. Note that with Farane R427A, there is a lower discharge temperature and lower power consumption. The other parameters are the same or similar. Now proceed to retrofit the air conditioning split. Because the split has a hermetic compressor, you do not change the oil. In spite of this, the use of Farane R427A will not cause any problems, although the efficiency will be slightly lower. Like in the preservation chamber, we'll start checking there are no leaks and the system works properly. Once more, we take note of the operating parameters with R22. Medium pressure of low side pressure gauge, suction. Low-medium temperature according to the gauge. Room temperature. Outdoor ambient air temperature. Evaporator exit air temperature. Electric power consumption. We evacuated the R22 from the system using a waste-labelled container and a refrigerant recovery unit. After the vacuum, and after checking that the vacuum level remains, we fill the system with Farane R427A. 95% of the 670 grams according to manufacturer procedure. We start up the system and then we check that the operating parameters are correct. At other times, it can be necessary to set the refrigerant charge. Note that with Farane 427A, there is a lower discharge temperature and lower energy consumption. The other parameters are again the same or equivalent. As we have proved, Farane R427A is certainly the simplest solution to replace R22, and the simplest solution is always the best one. Place an information label on the equipment showing that it is now charged with Farane 427A, and we finish the retrofit.